In this video I will show you how to write non-blocking code using millis. Some of you may have already seen my old video about millis, and it turns out I made a lot of mistakes. Now the first part of this video is my old video, so if you want to jump to the new part, I will provide a timestamp below. There is this function called millis. And millis is great because millis returns the milliseconds since Arduino started. Let's serial begin. I will store this millis inside of a variable. Now to store it, we need to know which type it has, because we can't just store it inside of a byte. That won't work. You can find out which type it has by moving the mouse over it, and then it reveals unsigned long. And we need to store it inside of an unsigned long variable. And then we serial.print line x. So as you can see, the result is 0 because our Arduino starts and then immediately sends the content of millis, which is 0 at this point. Well, let's do something else. Let's add a delay of 5000 milliseconds. The result is 4999. So pretty good. As you can see, these are the milliseconds since Arduino started. So how it works is Arduino starts up a timer in the background. So timer 0 is just incrementing a number in the background without us doing anything. And by calling the function millis, we actually take a look at this value. And we ask Arduino, please give us this value. And then we get back the milliseconds since Arduino started. And the nice thing is we can use it to write non-blocking code because delay blocks everything. You can't do anything while delay runs, except for interrupts. But if we get rid of delay and use millis instead, we can do so much more. Now let me show you what I mean. I will use millis to blink the onboard LED of my Arduino. So the first thing is pin mode 13, which is the onboard LED. I want it to be an output, and I will also create a variable called stored timestamp equals 0 unsigned long. And then inside of my loop, I check if millis is bigger than stored timestamp plus, let's say, 1000. So it checks constantly if millis is bigger than 0 plus 1000. So 1000. After 1 second, this becomes true and we jump into these curly braces. And then what I want is stored timestamp needs to be updated to the latest value of millis, because now a stored timestamp will increase and we will wait for the next second, right? And while we are here, I would like to toggle the LED. So I would like to digital write pin 13. And now the question is, should I turn it on or should I turn it off? Is it too much to ask for both? Now, if it is on, I would like to turn it off. And if it is off, I would like to turn it on. So what I really need here is digital read 13. We're almost there. So I'm assigning pin 13 to its current state. But that doesn't quite do it, because if it's high, it stays high, and if it's low, it stays low. What I need is to invert it. So I need to invert this digital read right here. In order to invert it, I will add the exclamation mark. So if it is high, then it will be low, and if it's low, then it will be high. Let's see if it works. And as you can see, the LED is blinking, and we don't have a delay. So we can do something else inside of our loop that is not blocked. Here I am 2 weeks later, and thanks to my viewers, not just older, but also wiser. I'm very thankful to also learn from you. So if I make new mistakes, please tell me in the comments. So it turns out there is definitely a problem with the overflow. This occurs after around 50 days, but still it's far from perfect. The first problem with this code is stored timestamp plus 1000 could be equal to the absolute highest number that can be stored inside of unsigned long. And if this happens, then this if statement will never be true again, because millis can't be bigger than the highest number possible. Because if you get bigger than the highest number, you will jump to 0, and that is definitely smaller than the highest number possible. This could be fixed by using greater than or equal to. Because if we don't fix this, we have a 1 in 1,000, in this case, chance that this code just stops working. And I don't want to be the one responsible for if you use this inside of a nuclear power plant or something crazy. We will have a chance of 1 to 1,000 if we get very close to the overflow that this code just stops working. And if you reduce the delay, the likelihood will increase. And this is horrible. Imagine your code is working for 50 days and then it suddenly stops working. And then I thought my code is finally perfectly working and everything is fine. And then I got a new comment. And that is another big problem when we come very close to the overflow. So let's assume that we jump into this if statement around 100 milliseconds before we go into the overflow of millis. Stored timestamp will be a very high number, very close to the overflow. We toggle the LED, everything looks fine. We exit the if statement. This is our loop. We jump back to the top. And now we check if millis is greater than or equal to our stored timestamp, which is exactly 100 milliseconds away from the overflow. And now we add 1000. So we actually create an overflow here. This number now is 900. So millis is definitely now bigger than 900. And our code will be executed. The new stored timestamp will be most likely the same, because this is very fast now. We are not talking about milliseconds, we're talking about nanoseconds in this case. The LED will be toggled again, and this will happen over and over and over again until millis finally overflows. This is horrible. And that was the point when I told myself I have to correct this video, because I don't want to be responsible for whatever you guys do with this code. Worst case, you build a nuclear power plant. I don't know. I just want to provide you with code that works. And this code is clearly not working. So we need a different approach. And it turns out Arduino has an example. And this example can be found in examples digital blink without delay. So the first thing is they store the current millis inside of a variable, which makes sense. So I will copy this one, because it could happen that millis exactly changes between these lines, which is not great. So to remove this problem, we can make use of this current millis variable, just so that it stays the same between these two lines. Now we store the current timestamp, and then millis rises, and we subtract the stored timestamp from millis, and this difference here is our delay. And then we just check if it is greater or equal to our delay. And the rest can stay the same. And now it works. If it still doesn't work, please tell me in the comments down below. I think this is a safe way of using this approach. Here comes your exercise. Using this new approach, I would like to have 2 LEDs blinking at different pace, one with 300 milliseconds and one with 400 milliseconds. So I will connect the red LED to my pin 2 and the green LED to pin 3. And then I also need ground. So the first thing is I don't need pin 13 anymore. I need pin 2 to be an output and also pin 3 to be an output. Inside of my if statement, I will change 2 every 300 milliseconds. Let's see how this works. Perfect, you see, the red LED is blinking with a speed of 300 milliseconds. And now I want the second LED. I will have one timestamp red and one timestamp green. And I will change it here too. So this is my red timestamp. Copy this code right here and change it to green timestamp. And it is pin 3. And I change it to 400 milliseconds. Let's see what happens. Perfect. So we see 2 LEDs blinking at different pace. If this video was helpful, please like and subscribe to this channel if you're ready to dive deep into the world of Arduino. Please comment down below if this code still has some bugs and will eventually crash. I can't think of any reason why. Thank you for watching. See you in the next lesson.